Deep dive into sklearn, linear model, RidgeCV. RidgeCV is a powerful tool in scikit-learn for performing ridge regression with built-in cross-validation, offering a robust and efficient method for finding the optimal regularization parameter alpha. Here's a detailed breakdown of its key aspects. Description: RidgeCV extends the standard ridge regression by incorporating cross-validation to select the optimal regularization parameter alpha. It seeks to balance model complexity with the risk of overfitting by penalizing large coefficient values. Class: sklearn, linear model, RidgeCV. This class represents the RidgeCV estimator. Parameters: alphas. This is a crucial parameter, defining an array of alpha values to be evaluated during cross-validation. Default 0.1, 1.0, 10.0. A small range, but often sufficient for exploring the regularization effect. Note a wider range of alphas, e.g. NP, log space -5, 5, 100 can be beneficial for finding the optimal value across a broader spectrum. Fit intercept determines whether the model should calculate an intercept term. Default true, generally recommended unless you are certain your data needs no intercept. Normalize indicates whether to normalize input features before fitting the model. Default false. Normalization might be beneficial if features have vastly different scales. CV defines the cross-validation strategy to be used. Default none, resulting in 5-fold cross-validation. Options: integer, e.g. 5 specifies the number of folds for k-fold cross-validation. CV splitter object, e.g. k-fold, allows for more complex splitting strategies. Iterable, e.g. train index. Test index provides a list of train test indices for custom splitting. Scoring specifies the scoring function to evaluate model performance during cross-validation. Default none. Default scoring for regression problems. Options: string, e.g. Negmian squared error, uses predefined scoring metrics from scikit-learn. Callable provides your own custom scoring function. Store CV values decides whether to store the cross-validation scores for each alpha value. Default false, enabling it can be helpful for inspecting the cross-validation results. Class weight: this parameter is irrelevant for RidgeCV since it's a regression model and doesn't handle class weights. Solver specifies the solver to be used for solving the ridge regression problem. Default auto automatically selects the best solver. Options: SVD singular value decomposition, often slow for large datasets. Kolsky decomposition, efficient for smaller datasets. SparseCG conjugate gradient solver for sparse data. SAG stochastic average gradient descent can be faster with large datasets. Saga stochastic average gradient descent with arbitrary penalty functions, more versatile. Methods: fitx. Y trains the RidgeCV model on the input data X and target values Y. During fitting, the model iterates over alphas and performs cross-validation to select the best alpha based on the chosen scoring function. PredictX predicts target values for new input data X using the trained model. Score X. Y calculates the score of the model on given input X and target values Y using the specified scoring function. Get params. Deep true returns a dictionary of the estimator's parameters. Set param. Squarg sets the parameters of the estimator using keyword arguments. Attributes: core, a numpy array representing the estimated coefficients for each feature in the linear model. Intercept, the estimated intercept term in the linear model. Alpha, the optimal regularization parameter alpha selected through cross-validation. CV values, a numpy array containing the cross-validation scores for each alpha value. Accessible only when store CV values true. N features in the number of features seen during fit. Feature names and names of features seen during fit. Example. Python. From sklearn, linear model import RidgeCV. From sklearn, datasets import load Boston. From sklearn, model selection import train test split. Load the Boston housing dataset. Boston load Boston. X Boston. Data. Y Boston. Target. Split the data into training and testing sets. X train. X test. Y train. Y test train test split X. Y. Test size 0.2. Create and fit the RidgeCV model. Model RidgeCV alphas 0.1. 1.0. 10.0. CV5. Store CV values true. Model. Fit X train. Y train. Predict on the test set. YPRED model. Predict X test. Evaluate the model. Print F optimal alpha model. Alpha. Print FR2 score model. Scores test. Y test. Key considerations. Choice of alphas. A wider range of alphas is typically beneficial for exploring the regularization. Effect. Use NP log space to generate a logarithmic range. Cross-validation strategy. Experiment with different CV options to find the best cross-validation approach for your specific dataset and problem. Scoring function. Select a relevant scoring metric that aligns with your evaluation goals. Feature scaling. Consider normalizing or scaling features if applicable to improve model performance. Interpretation. Examine the fitted coefficient score and the chosen alpha to gain insights into the model's behavior and feature importance. Conclusion. RidgeCV provides a powerful and convenient way to perform ridge regression while optimizing the regularization parameter through cross-validation. By understanding its parameters, methods, and attributes, you can leverage this tool to build robust and effective regression models.